Hi guys, in this video we will learn how to solve this problem by using superposition theorem. So to solve this problem by using superposition theorem, we have to consider some of the steps. So I am just following few steps, so you guys will follow the same steps. Yeah, before starting the problem, we need to know superposition theorem statement. Okay, so please read the statement carefully. I will explain you in a simple manner. So the statement tells us is in any linear bilateral network, the algebraic sum of the responses when applying individual sources in a circuit is equal to the total response of a circuit. So nothing. Here see how many sources are there in the circuit. 1, 2, 3. Okay, so sources means you know that whatever it is, independent or dependent, that is a source. Voltage source, current source, this is also dependent current source. Okay, but don't consider the dependent sources. Okay, in superposition theorem, please consider and please count only independent sources because dependent sources are uncountable. Okay, so please count the independent sources. Voltage source and current sources are the independent sources. Now tell me how many sources are there in the circuit. Okay, if you ask like this, you have to tell me that two sources are there. Okay, I'm asking about the independent sources. Okay, now there are two independent sources, so we have to consider each source at a time. Okay, there are two sources. Number of sources is equal to 2. Okay, whenever you are starting any problem, the superposition theorem problem, so you have to follow like this. So find the independent sources, that is 2. So it means to get the response. Now what is we need to calculate Vx. So to get Vx, we have to solve 2 times V1 plus V2. Okay, we have to find two voltages V1. Okay, V1 means any one of the source, two sources. You told me that two sources are there in the circuit. Any one of the two sources will be active and other one will be inactive. That time you will get one voltage, that is Vx. In Vx means in that place we will consider V1. So for example, if you consider 10 volts voltage source acting alone means this one only in the circuit, so the remaining sources will be inactive. So that time you will get V1. And second step, you have to consider current source will be inactive, then you will get V2. Okay, now please sum the like algebraic sum will be is equal to the total response voltage. Okay, don't confuse because I'm just telling you the theory only, right? So now you are getting bit confusion. I will solve this one. I found that sources is equal to, then Vx will be V1 plus V2. Now step 1, there is a step 1. Okay, when 10 volts voltage source acting alone, it means only one source will be there in the circuit. And you can ask me that what about the second source, so that can be replaced by internal resistance. Okay, I will tell you, 1 second, I will redraw this circuit by replacing the internal resistance of another source. Okay, this is the resultant circuit. So I drawn the circuit by replacing the other sources with their internal resistance. Okay, okay, I think you don't know what is the internal resistance of voltage source and current source. Okay, voltage source internal resistance is 0, current source internal resistance is infinity. So for 0 internal resistance, we are just making short circuit. For infinite resistance, we are making this as a open circuit. Now you tell me for current source to make to replace with their internal resistance means we need to do open circuit in the place of current source. So I did the same thing. If you see here, there is no current source. I just removed that and I make it made as a open circuit. For voltage source, we have to make it as a short circuit. So this one will come under the second step. Okay, you know how to draw the circuit by replacing with their internal resistance. And now we will find, see here, there is a Vx. Okay, why I still left that Vx? Because this is dependent. See, there is a voltage dependent current source, so we need to know what is Vx. So I just kept Vx as it is. And there I made another node with the name called V1 because the resultant of this first step will be the voltage V1. So you know that both two nodes, like two nodes are same, so it means Vx is equal to V1, that you know that. Kirchhoff voltage law at node V1. Okay, so Kirchhoff voltage law means the sum of the incoming currents is equal to sum of the leaving currents, right? So wherever the resistance is there, that I can consider as the leaving currents. So you have to consider the reference node, that is 0. So outgoing currents are V1 minus 0 by 4 ohms. See, at 4 ohms resistor, current is equal to voltage difference, like potential difference between two nodes. V1 minus 0, the direction I just made as a outwards, right? So V1 minus other node voltage is 0. So V1 minus 0, the difference between voltages is divided by resistance. V by R is equal to I. So this is the current flowing through the branch 4 ohm resistor, plus another one is V1 minus other node voltage is 10. There is a voltage source divided by 20 ohms resistance. So I wrote two currents, those two are outgoing currents. Now is equal to, there is a dependent current source, voltage dependent current source, that is incoming to the node V1. So I will write equal to incoming currents, that is 0.1 Vx. Okay, so you know that Vx is equal to V1. Okay, now V1 1 by 4 plus 1 by 20 minus 10 by 20 is equal to 0.1 V1. So this is 0.3 V1 minus 0.1 V1 is equal to, I will shift this 10 by 20 to the right, that is equal to 0.5, that is a constant, right? So subtract zero point 0.3 minus 0.1, 0.2 V1 is equal to 0.5, then V1 is equal to 2.5 volts. Okay, this is with our response output voltage at step 1. Now step 2, when 2 amps current source acting alone. So you have to redraw the circuit. So please observe here, I just replaced the voltage source into their internal resistance. It means short circuit. Okay, I just made the relation between voltage sources and internal resistance. See here. Okay, now same, apply KVL to, sorry, Kirchhoff current law. Apply KCL at node V2. Okay, so V2 minus 0 divided by 20 plus V2 minus 0 divided by 4. Okay, resistances are over. Resistances means I just made them as the outgoing currents is equal to incoming currents. Two current sources, this is the one current source, this is the second current source, these two are entering into the node V2. So what are the entering currents? 2 amps plus 0.1 Vx. Okay, you know that, where Vx is equal to V2, because both nodes are same, but we just differentiate with the Vx and V2. Now V2 1 by 20 plus 1 by 4 is equal to 2 plus 0.1 V2. 0.3 V2 minus 0.1 V2 is equal to 2. Is it 0 point V2 is equal to 2, V2 is equal to 10 volts. Okay, now you found V1 V2 by using step 1 and step 2. The resultant voltage by using superposition theorem, Vx is equal to V1 plus V2 from equation 1. So I just consider this as equation 1 because that is by using superposition principle. So V1 is 2.5 plus V2 is 10, that is equal to 12.5 volts. Okay, if you have dependent sources you have to find like this. Clear? This is matching with the answer. Okay, I hope you can understand this solution. If you have any doubt, please comment in the comment box. If you have any question, any problem to solve, please mail to the shankarkaliki20@gmail.com. Okay, so thank you guys. We will see you in the next class.